Hello, my name is Sean Cooney, and I'm a second year pediatric cardiology fellow here at Johns Hopkins. My presentation is called Perioperative Metabolomic Profiling in Neonatal Cardiac Surgery Identifies a High Risk Phenotype for Adverse Outcomes, and my mentor is Dr. Alan Everett. I presented this project last week at our Blalock-Taussig-Thomas Heart Center Research Day. Our work aims to improve post-operative outcomes in neonates undergoing cardiac surgery for congenital heart disease through the use of metabolomics. Although mortality rates have improved significantly over the years through advancements in surgical techniques, mechanical circulatory support, and post-operative intensive care, morbidity remains quite high. A big challenge in addressing this issue is the lack of risk models with modifiable variables. But metabolomics may offer a solution. Metabolites are the breakdown products of all the metabolic pathways in the body. In this field, metabolites are identified, and patterns in both individual and groups of metabolites are analyzed in order to identify risk factors for such things as post-surgical morbidity, insight into pathophysiologic processes that may drive these outcomes, and to discover unique targets for intervention. We collected and analyzed the serum of over 200 neonates undergoing congenital heart surgery from 3 different centers across the country. We then used machine learning statistical techniques to group patterns based on similarities in these metabolic profiles. What we found was promising. We saw that specific patterns of metabolite changes were associated with higher risk of morbidity, and other patterns were associated with lower risk. Furthermore, metabolite groups we identified corresponded with known pathophysiologically significant metabolic pathways like skeletal muscle breakdown for energy, inflammation, and inotrope anabolism. Furthermore, these metabolic profiles were not related to standard risk factors such as single ventricle heart disease or long cardiopulmonary bypass symptoms. This work is important for many reasons. We showed that metabolic profiles can be used to gain insights into the mechanisms driving postoperative morbidity in neonatal congenital cardiac surgery, and that this may help risk stratify our patients and identify unique therapeutic targets. We also showed that we can use machine learning to analyze such complex data. We're also supporting the notion of personalized medicine as we hope to better tailor care to our patients' individual needs by understanding their metabolic profiles. I'd like to thank the Everett Lab and our biostatistics team. Thank you so much for listening today.